All right, so, let's look at part B, and we're going to end up using the conjugate pair theorem, the complex conjugate pair theorem for this problem. And keep in mind that if we have zeros of 2i, then that will tell us that we also have negative 2i for a 0. It's conjugate. And so then also, if we have 3 minus 7i, we'll have 3 plus 7i. So that will give us, since we have degree 4, that will give us our 4 linear linear factors in the end. So, or 4 zeros. Okay, so 2i tells us that we'll have a factor of x minus 2i. Negative 2i will give us x plus 2i. And then it's a little tricky with this, but the idea is you just do x minus and then whatever you see here. X minus, and then put it in parentheses, 3 minus 7i. I'm going to subtract the entire 0. And then similarly, we'll have x minus 3 plus 7i. Okay, so here are our factors. And now what we want to do is we want to multiply all these. Now, what's nice about having conjugate pairs is that when you're multiplying, we're going to be using a factoring technique that we've seen earlier in the term when we're dealing with factoring, and also when we're multiplying polynomials. A squared minus b squared, or no, sorry, a plus b times a minus b is equal to a squared minus b squared. So you may remember that. We're going to use that here. So we know that I'm going to call this function p of x. And we're going to have x minus 2i, x plus 2i, x minus 3 minus 7i, and x minus 3 plus 7i. Now, we want to actually rewrite some of this for these two. We're going to want to rewrite it so it's in the form a plus b and a minus b. It's not quite in that form because we have x minus and x minus. We want x plus and x minus. So anything that is a that has the same sign, we're going to want to move to the left because we have a, and then anything that has opposite signs, we're going to put on the right. So just to see what I'm talking about, x minus, actually, I have it written right here. I can just use this. So we're going to rewrite this to x. So notice that x have the same sign, and negative, negative, 3, 3. Those have the same sign. So I'm going to distribute the negative to the 3, and I'm going to have minus 3. Notice that those have the same sign. And then, so that's like our a in this case. And then we're going to distribute the negative through, and that'll be plus 7i. So, and then we're going to do the same thing with this one. X minus 3, and then which we have from this, and then we're going to distribute the negative through here, and that will be minus 7i. So notice that x minus 3 have the same sign, so that's like our a, and then these have opposite signs, so this is like our b. So now we have the a plus b, a minus b form, and it'll be easier to multiply. So actually we're going to rewrite this in the form we just found. Okay, so we're going to rewrite this as x minus 3 plus 7i, and x minus 3 minus 7i. Okay, so you'll see how this works out. Here's the easier example. It's kind of nice. The 2 minus 2i, or x minus 2i and x plus 2i. So when we apply this, we'll have x squared minus 2i squared. Because we have a squared minus b squared. A squared minus b squared. So notice that this is like our a, this is like our b. So that's our result when we have a squared minus b squared. And then this is going to be multiplying, and so we have to multiply this conjugate. And notice that we will have x minus 3 squared, because this is like our a, as you can see. So that's x minus 3 squared, a squared, minus b squared, because 7i is like our b. So a squared minus b squared, a squared minus b squared. Okay, so this results in x squared, and then this is, so 2i squared is 4i squared, which will result in plus 4i. It will change the sign because I squared is negative 1. Okay, and then we have x minus 3 squared. X minus 3 squared, you can work this out, but you'll notice that this is x squared minus 6x plus 9. And then minus 7i squared, that's plus 7. Or, sorry, plus 49. And so hopefully you see that. 7i squared is minus 49. You'll notice it'll simplify to that. So minus a negative 49 is plus 49. So now we, oh, sorry. There should be an I here. It should just be plus 4. Okay, now we just need to combine like terms right here. And so this right here will be 58. I'll just do that really quickly. So now we have x squared minus 6x plus 58. So I'll cross that out to show you that we just simplified that. 58. And now, so we want to multiply this out. And you should know how to do that. So we'll have x squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. And then we have x squared times 58 is plus 58x squared. And then we have 4 times x squared is plus 4x squared. 4 times negative 6x is negative 24x. And then 4 times 58 down there. That is 116,232 plus 232. And then we have, I'll do it in orange or green. Let's do green. Oh no, that's all of them. And then we'll combine like terms. And we have x to the 4th, negative 6x cubed. There's nothing to combine there. And then we have x squareds here, plus 62x squared, and negative 24x, plus 232. All right, so let me know if you have any concerns, and I'll be more than happy to help. I understand it can be a little bit confusing, especially dealing with the 3 minus 7i and 3 plus 7i, but hopefully you understand how we needed to get in the form a plus bi, a minus bi, and that little manipulation right there, and hopefully you can adapt that for any problem you see in your homework or on a test. And yeah, anyways, that's what we have. P of x, our function P of x, is equal to this, and this function will result in the 4 zeros that we determined: 2i, negative 2i, 3 minus 7i, 3 plus 7i. All right, let me know if you have any concerns.